I will consider a problem in special theory of relativity where it may appear as if the law of conservation of momentum is being violated. There is a system of two objects A and B. Each has mass m. As seen from an inertial frame S, A is moving at a velocity of 0.5 c and B is moving at a velocity of negative 0.5 c, where c is the speed of light. As you can see, the momentum of the system is 0. The objects A and B collide and stick together. There is no external force on the system. We saw that the momentum of the system is 0 before collision. So by the law of conservation of momentum, the momentum of the system after collision will also be 0. This means that the velocity of the combined body after the objects stick together is 0. So the momentum is conserved in frame S. Now we consider another inertial frame S prime which is attached to B before the objects collide. This means that S prime is moving at negative 0.5 c relative to frame S. On the right hand side, we study the situation from the frame of reference S prime. Before the collision, velocity of A is 0.8 c. We calculate this using velocity addition formula because in frame S, S prime is moving at negative 0.5 c and A is moving at positive 0.5 c. And if we use the velocity addition formula, then we calculate that the velocity of A in frame S prime is 0.8 c. Velocity of B in S prime is 0. This is because in frame S, S prime is moving at negative 0.5 c and B is also moving at negative 0.5 c. So the velocity of B relative to S prime will be 0. We use the momentum formula. We know that mass of A is m and the velocity of A we calculated as 0.8 c. So we calculate momentum of A and this comes as 4 into m into c divided by 3. Since the velocity of B is 0 in frame S prime, so the momentum of B will be 0. We add momentum of A and momentum of B. We find that the momentum of the system in frame S prime is 4 into m into c divided by 3. Let us see what happens after collision. In frame S, the combined body comes to rest and S prime is moving at a velocity of negative 0.5 c. On the right hand side, in frame S prime, the combined body moves at 0.5 c. This is because, as we saw, in frame S, S prime is moving at negative 0.5 c and the combined body has velocity 0. So what will be the velocity of the combined body relative to S prime frame? That will be positive 0.5 c. Now we calculate the momentum of the system in frame S prime. Use the formula for momentum. We find that the momentum will be 2m into 0.5 c divided by square root of whole of 1 minus 0.5 square. Here we are using 2m because that is the mass of the combined body. Remember that here m is what we call as rest mass in some books. So mass of A is m, mass of B is m, so mass of the combined body is 2m. We simplify and we find that the momentum of the system after collision in frame S prime frame is 2 into square root of 3 into m into c divided by 3. Let us summarize. In frame S prime, the momentum of the system is 4 into m into c divided by 3 before collision and 2 into square root of 3 into m into c divided by 3 after collision. The two are not equal. This means that the momentum is not conserved in S prime, but it is conserved in S because in frame S, the momentum of the system is 0 both before collision and after collision. But how is it possible? If the momentum is conserved in one inertial frame, it should be conserved in all inertial frames. So where is the problem? Let me give a hint. If you do the calculations correctly, you will find that the momentum of the system is conserved in frame S prime also. Here I have intentionally made a mistake. Now, can you find where the mistake is? I understand that those who are knowledgeable in relativity must have already caught the error. But can the students catch it? I will post the correct calculations in my next video.